Good morning, students. Today we will discuss the next topic, that is black body radiations. Till now we have seen that the light exhibit the properties of electromagnetic radiations, electromagnetic waves. But after further research, it was found that some properties of light are different from the properties of waves. It was noticed that light sometimes behave like particles. Understood? Now, before starting this black body radiation, just see how the light interacts with matter. Light matter से कैसे interact करती है. Okay? Now we know that white light is composed of different wavelengths. When it is passed through a prism, then all the different lights of different wavelengths get separated and we see a rainbow. That is a band of 7 colors and that is known as Vibgyor. Understood? Similarly, if we are taking a white light which is having different wavelengths, lambda 1, lambda 2, lambda 3, and we are passing through a particular body. So what will happen? Three things will happen. Either the light will be absorbed by that body, that means different wavelengths, radiations of different wavelength will be absorbed by that body, or it will reflect from that body. Reflect means जिस wavelength की light reflect होगी उससे उस object का या body का color पता चलेगा. Understood? And some of the radiations of a particular wavelength transmit from it. Transmit means कुछ उसके through pass होके बाहर निकल जाएंगे. Understood? That means three things will happen when we are passing a white light through a particular body. Okay? Now see, when we are heating a body, then what happens? Now see, this is a burner and this is a body. When we are heating a particular body by the help of a source, so what will happen? It emit radiations of different wavelengths, that is lambda 1, lambda 2 and lambda 3. Understood? For example, if we are taking an iron rod, so what will happen? When we are heating that iron rod, so what will happen? It becomes dull red. After that it becomes more red, then it becomes white and then it becomes blue. That means if we are plotting a graph between wavelength and intensity, so what will happen? As the wavelength increases at a particular moment, so what will happen? The amount of radiations will also increases. That means this is intensity, how much amount of that radiations are being comes out from that body after heating, and this is wavelength. As the wavelength increases, the amount of that radiations also increases. Now what will happen at a particular moment? This is point, this point is the maximum point, that means the maximum intensity of a particular radiations emitted of a particular frequency. But after that, as the wavelength increases, the intensity also decreases. Understood? This point, from this point to this point, this is known as lambda max. The maximum value, the maximum amount of the particular radiations which is having maximum wavelength comes out and we are able to see a particular color. Just now I have told, when we are heating an iron object, we generally see a red color, red hot. So that means it is having the maximum wavelength, that is having lambda max, maximum wavelength. Understood? We see only red color after heating iron because it is having the largest wavelength, that is lambda max will be red. Okay? Every body is emitting all type of wavelengths whenever we are heating any of the body. Understood? Atoms and molecules could emit energy only in discrete quantities, not in a continuous manner. That was told by Max Planck. He says that whatever radiations are being emitted by a particular molecule, they are being emitted in a discrete quantity, not in a continuous manner. So what he called them, he says that one packet of that energy that is being emitted from a particular body is known as quantum, and if large number of packets are being delivered from one place to another, then we can say that packet of energy is known as quantum. Understood? Now he says that energy of a quantum E, energy of a particular quantum of radiations is directly proportional to its frequency. Understood? Now if we are removing this proportionality sign, so we can write E is equal to h nu. What is h? H is known as Planck's constant and its value is 6.626 into 10 raised to the power minus 34 joule second. Okay, now Planck was able to explain the distribution of intensity in the radiations from black body as a function of wavelength or frequency at different temperatures. Okay, now see an example. What is the energy of a quantum of light of wavelength 700 nanometer? Okay, you have to find the amount of energy in the form of quantum, in the form of packets. Now what we will do, we just now I have derived the formula E is equal to h nu. Fine. H is Planck constant and nu is frequency. We know the formula of frequency is c upon lambda. What we can write, E is equal to h nu, yeah, E is equal to sc upon lambda. Now the value of h is 6.626 into 10 to the power minus 34 joule second. C is the speed of light in vacuum, that is 3 into 10 to the power 8 meter per second, and lambda, just now it is given 700 nanometer. What we will write, 700 into, convert nanometer into meter, the SI unit of wavelength is meter, multiplied by 10 raised to the power minus 9. Okay, after further calculation we find the energy of a quantum of light which is having wavelength 700 nanometer will be 2.8 into 10 raised to the power minus 19 joule. Okay, thank you.